So though the topics is VPC configuration, we are not going to discuss about the configuration part. We'll first understand what is VPC, then we'll get into VPC configuration. I'm just using this presentation to know what VPC is. Yeah. So VPC, virtual port channel. Virtual port channel. If you notice here in this picture, we got one switch at the bottom with two links, but connecting to two different switches on the top. So this is one VPC. These two links are bundled. Usually we bundle the interface that are connected back to back just on two devices like this. This is how we bundle most of the time. We call it as port channel, but what we are learning now is different. We got two separate hardware on the top, and we are expecting we are expecting a port channel between this. When I have two different switch on the top, port channel is not possible. Why it is possible? I'm getting two different switches identification. For a port channel, when the negotiation happens to bundle these two links, these two links should be connected to same switch ID, same switch. Only then this bundle will come up. That is how LACP is designed, PAGP is designed. But we are expecting a bundle here, which is possible. It is possible through VPC. Now, what are the advantages of this? The same advantage. See, what do you have advantage here? When I bundle two links, I can use both the links. STP cannot block my port. Likewise, when I can bundle these two links, though it is going to different switch, if I do some magic and do the bundle, if it becomes a bundle, then I'm not losing my bandwidth. If not, what has the problem? If I don't have this VPC, what is the issue? I'll not be able to use one of the upstream switch. If I don't have VPC, to prevent loop, it's going to block here. So this switch cannot be used. If this switch cannot be used, then this switch also cannot be used. Only this side, the traffic will flow. So all these resources on the right will be lost. We will not be able to use. To overcome this limitation of STP, we need to somehow make this two upstream switch. For some time I want you to ignore these switches. Just only focus on 1, 2, 3. 3 switches. Just these 3 switches. Yep, 1, 2, 3. Now, if you can do the magic of forming this ether channel between these 3 switch, you will be able to use all the resources. You can use the switch, you can use this link, this switch, so we don't waste any resource. VPC does this magic for us. How this VPC can do this magic? By virtualizing this two physical device. It takes this two physical device and forms a virtual device. So that according to the downstream switch, it won't be seen as two separate switches, these two will be seen as single switch. How a switch ID can be common for two physical switch? Not possible. Every switch has got its own unique identification, the unique MAC addresses. So if you are saying I'm going to bundle these two switch, I'm going to virtualize this two switch, you need to somehow manage to get a common switch ID. That is what this vPC does. Nexus operating system supports all these features. Normal catalyst switches do not have this. But there is one feature called VSS, similar to this in service provider track. So after you understand this vPC, the theory as well as the configuration part, I'll be showing you the difference between vPC and VSS. But VSS is somewhat similar. It helps us to do port channeling between three devices. VSS also does the same. I'm trying to take one picture which will be easy for us to use. This picture is sometimes, it is distracting because we got too many switches. Let us continue. See how nicely it is picturized here. Physically it is three devices. Physically it is three devices. But virtually it is one device on the top. What does that mean? It has got one common ID to negotiate to the downstream switch. When you can have one common ID to negotiate to the downstream switch, when you have one common ID to negotiate on both the links to the downstream switch, port channel is possible. Now, how this common ID is generated? See, for this feature vPC, one MAC address is reserved. Yeah, so Cisco has got a reservation between these MAC address range. One of the MAC address will be used on these two devices. The last number, the last 0000, that will be different. It's going to be different using the vPC domain ID. What is domain ID? Actually, we will configure a number. When we form these two as one group, we will provide a number. You can see that here 10 is that number, 11 is the number, 12 is the number, 13 is the number. So we provide that number, domain ID 10. When we provide 10, the 10 sits here, becomes A here. If you say 11, then it is going to be B here. So a unique MAC address will be generated for each vPC using the domain ID. The domain ID who gives? We only give. So let us take, for example, the switch now has got a MAC address 0026 0BF1 F00A. That will be the MAC address for this virtual switch. So there will be another MAC address F00B for the second vPC. So the same two switch but different virtualization. though it is physically same to switch, according to this it has got its own switch to form bundle, and this has got its own switch to form bundle. So for every single VPC domain ID, there is going to be a MAC address. See, this is how they solve the problem. Now both the switch are seen as single switch, one single switch with one common ID with which it is going to negotiate, and this is also going to negotiate with one common ID. The port channel comes up. So you may have many port channels, virtual port channels with two switch on the upstream. Downstream is only one switch. You cannot have more than 3 devices in a VPC. Repeating again, you see how many devices you see? 1, 2, 3 devices. Likewise here, if you take, this is 1, okay, let's say this is alpha, this is beta, this is only 3 devices. Alpha. So you cannot have VPC with 4 devices or 5 devices, only 3 devices, 2 upstream device and 1 downstream device.
Okay.
You see here, this is also allowed. You know, some servers may allow NIC teaming, right? You know, you team these 2 NIC cards, NIC teaming.
Okay.
NIC teaming. It may use LACP or it may use on mode. That doesn't matter. If this side is on mode, you can also have on mode here. LACP, you can also have LACP here. You know what is LACP, no?
Yeah.
Yeah, right. So according to the downstream switch, there is no additional configuration needed. According to downstream switch, it is just forming a ether channel, forming a port channel. But only this switch has got some extra work to do. I need to combine these 2 switches to one switch so that it will resemble, it will appear like this. This will appear like this. See, these are all the various ways you can have this port channel. This may look a little bit complicated. Let us not go to double-sided VPC. Let us finish first the one single-side VPC. Now, I would like to. This is the page that I would like to cover next. This page teaches us a lot of fundamentals about VPC. So we saw that we want virtualization here. We want to combine these 2 physical switches, one virtual switch. We want a virtualization here. We want to combine these 2 physical switch to one virtual switch. What is needed? What are all the building blocks? Number 1, you need a VPC peer link. Number 2, you need a VPC keep alive link. Number 3, we need to provide a VPC domain ID. These are the building blocks. And then the VPC member port. Let me go back to the first picture. This is more clean with avoid confusion. So this bundle that you see here is what called as VPC peer link. Now this dotted line that you see here is called as VPC keep alive. link. VPC peer link, VPC keep alive link.
Correct.
Now VPC peer link needs to be a high bandwidth link. So what we do is we take like 10 gig two links and we bundle it. See, this is not VPC. This is just to have a fast peer link. The peer link need to be a fast link. We need more bandwidth. Why? These two boxes should now appear as one box, which means they need to quickly synchronize between them. Fast synchronization. The MAC table need to get synchronized. The time need to be synchronized. The clock need to be synchronized. All things like VLANs and many more things. For the fast synchronization, you need a bundle there. This is normal port channel. Fine. But there is a limitation for this. What is the limitation? This port channel should be LACP only. First of all, Nexus won't support no PAGP. You know PAGP, right?
Yeah.
Okay. Please don't forget this. PAGP is no, though it is a Cisco's protocol, PAGP, even though it is a Cisco's protocol to form Ether channel, now Cisco has removed it from new devices. In Nexus you won't find PAGP, only LACP. So you cannot go on mode also, not allowed. It should be a dynamic negotiating protocol. On mode is not a dynamic negotiation. On mode is you turning it on manually. So you should not use on mode. You may use on mode here and here, but for the peer link, what link is this called as? Peer link. Between the peers, between the peers, we call it as peer link. This need to be a layer 2 trunk high speed link. Yeah, a layer 2 trunk high speed link is what we need. That's what peer link is. It's going to be a layer 2. Understand. It's a layer 2 link. So do we have any IP address on the port channel? No. It's just a layer 2, but it needs to be a trunk. You cannot simply take 2-access link and bundle it and dedicate it for peer link. If you do that, VPC will not come up. It needs to be a trunk link also. And for high speed we do what? Port channel. And the port channel should be LACP enabled, LACP negotiated. Port channel needs to be LACP negotiated. High speed link, the port channel need to be LACP enabled. Right. Now we saw about the peer link. What is next is the keep alive link. This link. Keep alive link is a layer 3 link. Keep alive packets are sent only in layer 3 links. You know that, right? On router interfaces, on all router ports, keep alive packets are sent. BGP sends keep alive. So definitely it should be a layer 3 link. Now why do we need this? First we saw peer link. which is a layer 2. We understand that this peer link is needed for this 2 box to get synchronized faster. And what for this keep alive layer 3 link? What is the purpose of keep alive link? Why do we need this? We need this in order to have a secondary check, like a second opinion. See, for example, if this port channel breaks, assume it should not break, it won't break. Why it won't break? Because we are doing bundle, a redundant link now. Even if one of the link goes down, there will be another link. There are very rare chances. What I am saying is very rare chance. Assume for some reason both the links in the bundle gone. The port channel between these two switches gone down.
Yes.
Now the switch now should not get confused. The switch should know that the other switch is still alive. See, if this goes down, I can know through this keep alive link that the other switch is still alive, so that I can continue the VPC services. See, if both are not responding, both layer 2 and layer 3 is not responding, then what it will do, what this switch will do, to prevent loop, it will fall back to STP and this will start blocking and the VPC will break. It should break, no? If, or in another word, let's say one of the switches has gone down. If this switch has gone down, definitely both will not be working. So now this switch should take the responsibility of all the traffic. Earlier in VPC, both the switch will be active. What does that mean? Half of the traffic will be going this way, half of the traffic will be going this way, active. But when the switch goes down, what we expect all the traffic to go this way. For the decision to take, this switch uses these two links. If both are not responding, which means according to switch B, A is dead, and switch B will say, from now on I am the active device for all traffic. Now as soon as the keep alive and peer link comes back, B will say, I'm not active for all, but I'm active for only the 50% of maybe all the odd MAC address or all the even number MAC address. So what I'm coming to say is, for one switch to know that the other switch is still alive or not, we need this two verification. If port channel goes down and when the keep alive is up, what does that mean? It means B should not take all traffic. Why? Because A is still alive. How it knows? Because through keep alive it is receiving the pinging. Keep alive packets are coming, so B have to continue with what it is doing so far. It should not remove VPC. It should not say I will take all the VLAN, all the traffic. It should continue with the service, the VPC service, without any change. So it is good. We have two verification. If any one of this works, that confirms that the other neighbor is alive. Only when both fails, it proves one that the other one is dead. That's why we need two. So there is a special keep alive messages that will be sent as a layer 3 packet between these two switches. So this link, as I said earlier, it's a keep alive link. There is a ping, ICMP ping going between these two interface. Mostly we will be using management interface on both the device. Management interface has got an IP address and they will be in same subnet. So we need to make sure that these two are pingable. That is very important. They need not to be in same subnet also. Even if they are in different subnet, it is okay, but all that we need is reachability. Layer 3 reachability. So they will be keep on sending the ping message. And peer link will also be sending some sort of ping message between them, synchronizing between them, or layer 2 synchronization happen. This is a layer 2 fast link. Now if layer 3 link goes down, keep alive link goes down, layer 2 is alive. So the switch knows that the other switch is not dead, it is alive. So they keep continuing the VPC service. What will not happen is, if a new MAC address is learned here, when this is down, it won't get synchronized with this. That will be the problem.
Yeah.
Only when something new happens, there won't be synchronization. Otherwise it won't. See, this is very rare case. What we are talking is very rare case. We have two links in the bundle so that this will never, what we discuss will never happen.
Yes.
And also, you know how we bundle? Let's say it's a Nexus 5000 series. If it is Nexus 5000 series, we'll take one port from this slot, let's say slot number 3, another port from slot number 5. So that, see, this is from slot number 3, this is from slot number 5. Here also slot number 3, slot number 5. Why we do that? If this line card goes down, only this link will go down. The other one is still alive. See, that's the idea. See, I have worked with these devices physically. I know how this works. You know, they will have a redundant power supply.
Okay.
If you have up to 3 power supplies, all the line cards will work. But if you lose this one, some slots will go off. Some slots will go off. Even that should not disturb this vPC, for which I take from different slot and bundle it. That's the idea. So even if one of the line card goes down in the switch, the vPC will continue its service. Only when both the line card goes down, which is very rare case, for both the line card to go down, maybe this also gone down. But there is a keep alive link, layer 3 link here, from slot 7, let's say. So that is still there, no? So vPC will still continue. Only when all the power goes down, the entire box will go off. So now all traffic will go this way. See? So vPC, it's not just, you know, combining two switch and having one common MAC address like HSRP or VRRP. Not that simple. This is well designed one. This will never go down. Only when there is a big power outage, all the power source to this is gone, only then the vPC will break. To check whether the vPC need to continue or to break, you got two checking mechanism. One is layer 2 peer link, the other one is layer 3
Keep alive.
keep alive links. So we should not forget these two. Peer link, the purpose of peering, and purpose keep alive. Do we use keep alive link for synchronizing between the device? No. It's just a heartbeat. Pop, 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 pop. That's all. It's just a heartbeat. I'm here. I'm alive. I'm alive. Both boxes will be sending a layer 3 packet saying I'm alive. I'm alive. I'm alive. Yeah. Fine. So what is this port called as? This port will be called as member port. What about this one? Member port.
Yes.
Right, member ports. So in this picture we know names of these ports: keep alive, peer link, member port. This is VPC domain, meaning these two are aggregated, these two are bundled, these two are virtualized as one switch. So VPC domain, these two are under VPC control, VPC domain. To identify the VPC domain, we give a number. It can be any number, maybe 10. VPC 10. VPC 10 member ports are this one and this one. VPC 11 member ports are VPC 10 member ports are this one and this one. VPC 11 member ports are this one and this one. You see, different domains.
Yeah.
So this is one triangle, and then this is another triangle. This is another triangle. So all these are different domain. Even though the switch is same on the upstream, on the top those switches same, no? Even though the switch is there same, they got different MAC address because they have different domain ID. I showed you, no, the MAC reservation. The last bit will be different for each domain, so that they will have a unique domain ID. See, every switch has got its own MAC address. But when you take two switch and virtualize as one virtual switch, that virtual switch, the switch that you are creating now needs a identification, right? That needs a MAC address, right? Every device needs a MAC address. Whether it is physical or virtual, if you call it as a device, the device should have a unique ID. So, in all the Nexus devices, this range of address will be always there in the operating system as per the Cisco standard. So when you enable VPC feature, what happens is this MAC address will be ready for use. See, in Nexus everything is feature based. You have to enable the feature before you configure.
But each port having MAC address instead of each switch, each port having MAC address, right?
If it is a layer 3, only then that MAC address will be taken into consideration. Layer 2 port MAC address will not be considered. Layer 2 ports, if the switch port is a layer 2 port, then the MAC address will not be considered while routing. Only a layer 3 gateway ports are considered. Now, so we don't take it under account the layer 2 interface MAC address. We now focus only on the switch MAC address. For the entire switch, we need a common ID. You have seen, right, when you do STP, show spanning tree, you will see a bridge ID. You will have one common MAC address for the entire switch, right?
Yes.
So that is the MAC address now we have generated for this virtual switch. So only from this range. So if you will see a MAC address like 260B F1, then F1 or F2, if it is 0BF, especially 0BF, if you see a MAC address like 26 0BF, then it is VPC. Alright, only Cisco's device will have this MAC address. Now, VPC domain ID gets added at the last. How many VPC domains you can create? Many as you want. There is no limitation, but the limitation is you cannot have VPC with 3 upstream. That is not possible. You cannot have this one. Not possible. That is not possible. Only 2 devices as upstream. Only 2 devices can be combined together. Now we have seen so far peer link, keep alive link, member ports, VPC, domain ID, and we also saw how the domain ID will be used to create a unique MAC address. Yeah, from the pool an address is taken and the domain ID will be attached to the end. Next is, if I will have a switch here and a computer here which wants to communicate to a computer here, please understand, we have a computer A which wants to communicate to B, but B, if you want to reach, you need to use the member port, right? Now the traffic that is entering into a port which is not a member port, the traffic that is entering into the port which is not a member port forwards the packet to a member port so that it can reach the destination. If it is so, then these port will be called as orphan port. Orphan port. It's not a member port. VPC member port, if traffic from a VPC member port goes to a non-VPC member port, that non-VPC member port is what called as orphan port. Either this way or that way, A sending to B or B sending to A. The packet is going to now go from an orphan port to a member port and vice versa. So we are understanding what orphan port means here. The port which forwards the traffic into the member port to reach the destination is the orphan port. The port which is not a member port but forwards the packet towards the member port so that it can reach a destination, they are called as orphan port. Yep. So let me go back. So we understood now what is orphan port. We understood now what is member port. We know peer device. We know keep alive link, peer link. Peer link is a keep alive link is a layer 3 link. VPC domain. Don't worry about this switch. This is an access switch. We'll talk about those things later. Now what is the VPC VLAN means? Please understand. VLANs are VLANs. Normally you create a lot of VLANs, but some VLANs are allowed to pass through the peer link. Not all the VLANs are passing through the peer link. We allow some VLANs to pass through the peer link. Those VLANs are called as VPC VLAN. Those VLANs that are not allowed on the peer link, which means traffic goes like this, it cannot take a right turn, it can only go straight. Those VLANs that are not member of peer link are called as non-VPC VLANs. Meaning, if a VLAN is allowed in a peer link, it's a VPC VLAN. VLAN carried over VPC peer link See, the VLAN that is carried over the VPC peer link and used to communicate via a VPC. As soon as a VLAN is defined on the VPC peer link, it becomes a VPC VLAN. So if you take any VLAN and assign it to a peer link, it becomes the VPC VLAN. What is non-VPC VLAN? The VLANs that is not part of any VPC. The VLANs that is not part of any VPC and not present on VPC peer link. They are called as non-VPC VLANs. And do you have any question on this VPC VLAN and VPC, non-VPC VLAN?
How a VLAN is a part of VPC? That I doesn't get it.
No,
how a VLAN become a part of.
We allocate this port channel to some VLANs. We make it as a member.
Yes.
So that those VLAN traffic may go through this peer link. Along with that,
Allowed VLAN.
allowed VLAN. Those allowed VLANs are called as VPC VLANs.
Okay.
Other VLANs are non-VPC VLANs.
But it is mentioned in the definition, you mentioned VLAN that is not part of VPC. That means what?
See, there are two types of traffic we see. One, understand this. Now, some traffics are going this way and that wants to use the VPC peer link for some reason to go somewhere. Those are one type of VPC VLAN. There is also another VPC VLAN which is used only for the management between these two devices. See, these two devices need to synchronize, no? For that you will give a VPC VLAN. That is also another type of VLAN. So including that VLAN, one management VLAN we will give for these two boxes to synchronize. Plus you will be allowing some VLANs. That is what allowed VLAN. Some VLANs, even that is also a VPC VLAN. Other than this, VLAN that are not part of any VPC, meaning they are not used as a management VLAN for VPC and it is not present on any member, meaning this member ports don't belong to that VLAN. Let's say VLAN 200 is not VLAN 200 is only in the orphan, not even orphan port. VLAN 200 traffic never enters into any VPC link, any VPC member port. They have no connection. So some traffic comes like this, they go like this, and they belong to VLAN 200. They are not part of VPC at all in any manner. Their traffic never enters either member port nor the peer link. Those VLANs are non-VPC VLANs. Yeah? Alright. So, now important things are covered now. Next is the benefits. Why do we need VPC? VPC is a virtualization technology that presents the paired or two nexus device as unique layer 2 logical node to the access layer device, meaning downstream device. The downstream device may be a switch or an endpoint device like a server where you do NIC teaming. VPC belong to multi-chassis ether channel. Okay, this is also one terminology the other vendors will use. Multi-chassis MCPC, they will say, the other vendors. Multi-chassis port channel. Have you heard about this? I have heard many times from other vendors. Cisco don't call it as like this. Port channel is only between two devices, but the other vendors also have similar to this VPC with their own name. One of the industry standard name for this VPC is MC, multi-chassis port channel. Cisco gives name multi-chassis ether channel. Instead of port channel, Cisco calls it as ether channel. Both are same name.
Okay.
MC, EC or MC, PC, all are same. But I have seen like extreme networking, they call it as MCPC. Okay, now virtual port channel allows the link that are physically connected to two different Nexus switches or 5000 series device to appear as a single port channel to the third device. This is the third device. Down is the third device. Sorry, I think I'm using the wrong. Here, the down is the third device. This down one is the third device. For the third device, this two appears as one single device. Allows the link that are physically connected to two different Cisco. Next, the third device can be a switch, can be a server, can be a firewall, can be a load balancer, or any other networking device that supports link aggregation, LACP or on mode, NIC teaming, anything. Now, what are the benefits? Benefits: you don't need to have STP anymore, so we are not subjected to that blocking ports. We can make use of all the ports. See, if there is no VPC, then we are subject to the STP. Uses are all available uplink between the switch. So the hashing algorithm is used and load sharing will be happening according to the algorithm. So allows dual homed server to operate in an active mode. As I said, this will be active. Both will be active. Offers dual active first hop redundancy, default gateway for the servers. Each peer device in the VPC domain runs on its own control plane. Listen, this is important. Each peer device in VPC domain has its own control plane, and both the devices work independently. See, both the devices are synchronizing each other, there is no doubt, but they got their own control plane and data plane. This is the big difference between the VPC and VSS, which is not in our curriculum, but which is there in service provider. VSS, for both the devices you will have one control plane in VSS, whereas in VPC you will have separate control plane for each upstream device. If control plane and data plane are separate, then it is VPC. If you got one control plane and two different data plane, then it is called VSS.
Same like FX.
Same like what?
FX.
Sorry, I didn't understand.
FX.
FX is different. FX is fabric extended. That's the port virtualization. That is a remote line card. That is different story, no? Maybe I'll take FX later for you. That is different. So we saw the benefits of VPC. Using VPC, you gain immediate operational and architectural advantages, simplified network design, built high resilience and robust layer 2 network. Yeah, it's a layer 2 feature. It's not a layer 3 feature. VPC is a layer 2 feature with high resilience, meaning what is resilience? High flexibility and robust scalability. Enables seamless virtual machine mobility and server high availability cluster. So if you are using a server with NIC teaming, the server will never go down, and because you got double the bandwidth, the seamless mobility will be seen.
Yeah.
So more bandwidth, increased bandwidth, grows the size of the layer 2 network. Yes, if you are depending on STP, we always lose half of our resource.
Yes.
With VPC, we get double the resource. So VPC feature is included in base NXOS software license. So you no need to additionally pay for this. It is available in the very base license of Nexus. See, if they ask money for this, then no one will buy Nexus. Nexus is seen something special because it has got this type of feature. So definitely this should come in this base license, and it is. VPC also leverages native split horizon loop management provided by port channeling technology, meaning a packet entering on the port channel cannot immediately exit on the same port channel. Very good. You know, this I'm going to teach you later with nice picture how in this loop is prevented. You see, but I'll just put it in simple way. The traffic that goes to this one, if it takes the peer link, it is not allowed to come back. It is not allowed to come back on the other member port. That is what it means, same port channel. Packet that was entering in one member port cannot leave the other member port. You understand? It cannot leave the other member port. So loop cannot happen.
Okay.
That is how VPC prevents loop. So I think the important introduction is done. So in our next class what we'll do is we will talk about the failures. What if that link fails? What if this link fails? How the other will detect the failed device? What will happen to the traffic flow and so on? We'll discuss on that. Afterwards we'll talk about the configuration part of it. Yeah. So I'll stop here today.